Obrigado, professor Dr. Terry Anderson. Olha, gente, eu já estou na ABED há muitos anos. E quando a gente assiste uma palestra como essa, eu fico pensando no professor Lito, no professor Formiga, e algumas pessoas da diretoria da ABED, que eles passam o ano de uma forma assim, quase sádica, pensando quais as palestras que eles vão trazer, quais os palestrantes que eles vão trazer para nos deixar incomodados, inquietados, preocupados e até com dor de cabeça. Eu tinha cabelo quando eu comecei a vir para a ABED, olha a situação que eu cheguei. Professor Lito, o senhor realmente gosta de mexer com a gente? Uma palestra como essa, sobre conectivismo especialmente, e as propostas embutidas nessa nova geração de EAD, certamente nos provoca muita reflexão e a gente sai daqui com uma certa dor de cabeça para conseguir imaginar como que nós vamos aplicar e sabendo que são caminhos aí disruptivos de onde nós precisamos chegar. A nossa próxima palestra eu já percebi que não vai ser diferente e vai aumentar a nossa dor de cabeça e a nossa inquietação. Com o professor Dr. Gonzalo Frasca Larnaldi. Ele é professor doutor na área de videogames pela Universidade de Tecnologia da Informação de Copenhague. O professor doutor Gonzalo Frasca é um designer de jogos, pesquisador acadêmico, veio do Uruguai. Ele estudou muito a teoria dos jogos, pertence a um grupo chamado ludologistas, que consideram os videogames como simuladores com base em regras. Eles veem o jogo como o primeiro meio de comunicação de massa simulativo, o que significa uma mudança de paradigma no consumo de mídia e na produção de mídia. Ele estudou durante vários anos a questão dos videogames no Centro de Jogos de Computador, na área de investigação e pesquisa da Universidade de Tecnologia da Informação de Copenhague. E hoje ele é CEO de uma empresa de design de games educativos para ensino de matemática. A empresa se chama Okidoko. E ele vai nos brindar, então, com a sua exposição nesse momento. Professor Gonzalo.
Bom dia. I'm going to speak English, though, because my Portuguese is limited to bom dia e o Uruguai é melhor o futebol que o Brasil. Okay. No. Somebody told me to say that. I don't know what it means. No. So my name is Gonzalo. I need to walk in order to think. I don't know. I was born that way. But I'm going to ask you for two favors. The first, because I'm Uruguayan, I really need some chimarrão. So if somebody can share it with me, that'll be great. Some mate, no? Okay. And the other favor is very simple. What I want to do, hold on, this thing is not working, so let me, there you go. So, would you be so kind to stand up? It's going to be just for 1 second. Yeah, everybody you can do that? Okay. So, this is a very short thing I'm going to ask you. It's about superpowers and kryptonite. Okay? Let me tell you what my superpower is. My superpower is something that I either do quite well or enjoy doing, which is not necessarily the same thing. In my case, it's making games. And my kryptonite is that I talk too much and listen too little. Okay? So the idea is that you introduce yourself to whoever is next to you, and each one of you tells each other what you think is your superpower, something that you like or do quite well, and what is your kryptonite, something you don't do so well and you would like to learn to do. Okay? Go ahead. Sì? Oh, ok. Tá bom. Obrigado. Okay? Well, are you done? Okay. Well, if you want, you can sit down. If you want to stand up, that's okay. The power of the microphone has given me mate, so mission accomplished. Thank you so much. Okay, now I have too many things and too few hands, but well, this is a little game I usually, the thing about large events that I don't like is that it's very hard. It's very easy to be alone and not to meet a lot of people. So this is a game I usually, when I have to introduce, especially game students, people who were very different backgrounds. Here everybody has a very common kind of reason to be here. But the Kryptonite superpower thing allows me to get people to know each other. And especially sometimes you find that your superpower is somebody else's kryptonite or vice versa. And then you get to realize, hey, we can help each other. Anyway, the other reason I did this is that the human beings were not designed to be sit down for 1 hour. So I wanted your blood and caffeine to flow to grab your attention. Okay, now that I hacked that, as I said, I'm from Uruguay. And I'm going to start by telling a little bit about a social experiment that we've been doing there. Oh, when I'm president of Uruguay, this is going to be our flag, by the way. Anyway. So, Uruguay is that little part of Rio Grande do Sul where we speak Spanish. Okay? And we're tiny. We're really small, only 3.5 million people. And education down there is not in the best possible moment of history. However, we did this strange experiment. The government bought a computer and now a tablet to every single boy and girl in school. So if you have a kid, come to Uruguay, we'll give you a free computer. Okay? If you have 2 kids, we'll give you 2. Or maybe if you call right now, we'll give you 3. Not only this, but also every school is online, and 75% of every boy and girl has free Wi-Fi within 300 meters of their houses. It's quite an interesting thing what's happening. It didn't have any impact on reading comprehension or math, but it's giving kids the ability to escape from school, which right now it's a very good thing. To dream, to do stuff, and especially for girls, we men were kind of bossy. So in families where they had a computer, usually the brothers will tell their sisters, you're playing it wrong, you're doing it wrong. Well, now that everybody have their own computer, girls can do whatever they like. And there's a lot of interesting things happening. We have a secret plan for taking over the world, which is teaching cows to get online. But when we do that, we'll take over first Brazil, and then we'll keep going up north till Canada. Okay, so watch out. So, I make video games. I've been doing making video games for like 15 years now, mainly for animation companies. I have worked mainly for Cartoon Network, but also for Disney, Pixar, Lucasfilm, plenty of games based on TV shows and films for kids between 6 and 12-year-olds. That has been the focus of my work, of my non-academic work, at least for 15 years. And I'm here to talk about education, math learning, and games, and game tutorials. Let me start by saying that games are trendy now. It's cool to talk about games and education. Okay? So be aware, it's a trap. Don't believe what everybody says. Just a little mistrust is usually healthy. games are not here to solve every world problem starting with dandruff. But they can contribute to a few things, and that's what I'm going to be talking about. I'm going to be talking about game tutorials. This is the thing. We game developers have quite a challenge. We need to have games that can be easily learned. If kids don't learn our games within a few minutes, while having fun and while being challenged, they just switch to a different game. Unlike my students, they're not trapped in a room where they cannot escape. They actually have too many options. So we game developers, over the decades, we had to develop techniques for getting games to teach themselves in an effective way, or we don't eat and we don't pay rent and stuff. So it's very important for us. So you may know Super Mario. Super Mario is getting old, actually. I mean, every time I show this, I'm like, well, maybe I should update it, but let's... has somebody never played Super Mario? No? Wow. You? Okay. After my talk, we can play together. So, how do you learn Super Mario? Well, first, it really depends on your age. If you're over 50 years old, pretty much, the relationship with technology is that of the floating finger. What does it mean? If an adult gets a new technology, this is what he or she does. No. If a kid gets a new technology, they just tap everything to see what happens. Okay? And that's actually the basis for science, for scientific thought. Just try stuff, see what happens, learn from your mistakes or from what you did right, and iterate and improve. That's why kids, when they're playing Super Mario, they tap the buttons and they realize Mario can move left and right and jump. So nobody reads a 400-page book in order to learn Super Mario. If you're doing that, well, good luck with that. Why Super Mario and every single other game based on levels are so effective so kids, after a couple of hours, can play really complex systems? Well, they break up all the learning process in very small parts while trying to remain challenging. And this is the thing. I said that games are trendy now, but usually they're trendy for the wrong reasons. We have this patronizing attitude towards games. We think, okay, young people are bored. What do they like? Games. Okay, we're going to give them games, so they're going to enjoy whatever they hate, either their job or learning. Well, that's not the way it works. Because what is the opposite of boredom? What's the opposite of to be bored? Can anybody tell me? Excited. Anybody else? Engage. I would add challenge. The opposite of boredom is not enjoyment, is not fun. It's challenge. Fun comes afterwards. Because if you look at somebody playing any game, but also video games, they're not having fun all the time. They're not happy and cheerful all the time. Actually, when I make a game and my players start cursing at the screen, I know I'm doing my job right. Because they're being challenged. They have a problem to solve. A problem that cannot be too complicated or too easy. They're constantly being challenged. So let's go back to Super Mario. And imagine you're playing level 1 in Super Mario. And you run into this guy. You know he's evil because of the eyebrows. Okay? That's the international symbol for being evil. And so imagine that you're a nice person, and even you enjoy diversity and said, well, he looks evil, but that's probably just my bias. I'm going to pet this creature, and then it kills you. And then you're like, okay, now it's personal. And so I need to get rid of this. How do I do that? Well, if I touch it, I die. So maybe I just try to jump over it, and maybe I can do that. But sometimes by accident, I jump over it and step on it, and it disappears. It goes to video game heaven. So you learn that. Okay, those things are evil, and I know how to get rid of them. That's level 1. But then on level 2, you find a turtle, and the turtle doesn't have evil eyebrows. He's actually quite happy. But of course, all you know in your grammar of the game is to jump over stuff. And if you jump over the turtle, what happens? What happens? It goes upside down, and then you touch it, pew! And then you're like, wow, that's weird. Turtles behave really weird in this very traditional, normal world with princesses and Italian plumbers. Okay. Later on, you find this guy. And he has spikes on his back, so you know that you cannot jump on it. And you're like, what? What should I do about this? Oh my God. Well, I can move, I can jump, but here I cannot jump. But I just learned before about this turtle, and I know that it just goes really fast, so I'm going to try to use that in order to get rid of this. And that's exactly how it works. So that's a game tutorial. A game tutorial has no textbook, no instruction. It gives you the right amount of information at the moment that you need it. And it also has an implicit message that is, knowledge is constantly being constructed. What you learned before is going to be able to help you afterwards. So that's the basics for tutorials. So I'm going to show you a few examples of, I'm not going to say experimental tutorials, but the use of the tutorial structure for learning. I'm going to be showing some of the really newest things that have been developed in the last few years that actually, unlike traditional video games in education have been around since forever, but 99.99% are just good for practicing, not for learning new stuff. So this category of strange learning games, I like to call them booktorials, which is a hybrid between a textbook and a game tutorial. Now let me show you the first example, which was done by a friend of mine called Chaim Gingold. This is a geology book, okay? I know geology is not the most sexy kind of topic, but this is a really, really, really interesting application. So this is actually the first digital book that you can call digital book, in the sense that most ebooks, or all the other ebooks, are about just adding multimedia features or hypertext. This is the first book where every single page, every single concept is not illustrated with a video, it's not illustrated with an image, but it's illustrated with a simulation. So Chaim actually worked for many years with Will Wright, the creator of The Sims and SimCity. And here you can see each one of these you can actually create glaciers, you can actually create volcanoes, see what happens. Every concept is illustrated by a small sandbox, no pun intended, that allows you to explore, and more importantly, to see what happens and to make mistakes. And that's one of the most powerful features of tutorials. They allow you to make mistakes fast and learn from your mistakes. This is only available on iPads right now. It will become available on other platforms later. But if you're interested in seeing how electronic books can deliver way, way, way more from what you... There's nothing like this anywhere else. So if you're interested in electronic textbooks, this is definitely something to be checking out. Let me show you shortly something I've done based on his work. This is a short online app. It's not available yet. It's going to be available for free in a couple of months for learning linear equations. And it uses the same structure, okay? It's basically pages, it's in Spanish. So basically you have there's also an English version. You have this designer who created this robot with a telescopic arm. And in every page, there's something you can do. Here, well, I know the results. You have to raise the arm in order to get the bolts at the right height. This is HTML5. It works on any browser. So you can click and make the robot walk. And now, for every step the robot makes, it will raise its arm 1, 2, 3, 4, 5. Okay. Now twice as high. The idea of this, there is this math teacher in Stanford called, a math professor called Keith Devlin, that he says the problem with learning math is that we use professional notation for it. It's like, he says that it's like learning music only through musical notation without never ever using a musical instrument. And so the idea of this is before actually teaching, learning linear equations and how to graph them, kids can have an experience and manipulate them. And so now you created your first skate ramp, and now you turn that into a remote control, so you automatize it. I'm making the sound effects, by the way. And now we can put, I don't know. And of course, the arm is going to be a Y, and the steps are going to be an X later on. But again, this is something that it's over after 10 minutes. Teenagers can use it before class or as homework. And now you get the stars, which is the international symbol of if you see a star, you need to get it, because that's how video games are. So every step has a tougher challenge, but they're not overwhelming. They're quite easy. Whee! Okay. And then the remote control breaks down, and you have to calculate just by hand. But anyway, this is just an example of something that. Hold on a second. I'm going back to PowerPoint. Okay. This is just an example of this booktutorial structure. 10-minute long, very short, but before you actually get the concept of slope, the concept of function or linear function, you get to manipulate it, you get to touch it, you get to play with it. So when the teacher tells you something really abstract and really disconnected at first with your everyday life, you can ground it to something that you're more familiar with it. Now I'm going to show you one of the most incredible, I mean, every time I hear educational game, I become suspicious. Because I told you, most of them suck. Suck is a technical word that I learned in my doctorate, by the way. That's the only way to describe most educational video games. But this is quite interesting. And you don't have to take my name, my word for it. This is actually, I'm going to show you the trailer. This is a game that teaches you algebra. And as I said, you don't have to take my word. An independent study from the University of Washington showed that 97% of children that played this game for an hour and a half learned how to solve basic equations. They didn't know how to do that before, they learned it afterwards. And this was not done on a small sample. Actually, 400,000 children were involved in this study because this is a game made in Norway, and the Norwegian government encouraged every single kid in school to play for a week with this game. It's kind of the vaccine against algebra. You would think that this would be available in every single school on Earth. Well, not. While it's quite popular, it's not yet there. Actually, if you go on YouTube and look for Dragon Box Algebra, you can see children, 6, 7-year-old boys and girls, solving algebraic equations. It's like, what? Like, you're not supposed to do that. Well, they do. It's quite challenging. I mean, it has some challenges. It does something very well. But the challenge is that knowledge that is within the game, how do you transfer that to the outside world? And there are some techniques on how to do that. I'm going to show you the same process on a game that I'm working right now for children. It's almost done. It's going to be available on iOS next month. And this is for school children. It's the first on a series of games for the basic algorithms for arithmetics. So this is about long addition, but I'm also working on long division. And the idea is, how can kids learn basic algorithms without going to school to learn it? They learn it on their tablets, on their computers. However, this is not supposed to replace the teacher. The teacher is there to bridge that new skill and connect it to other things. That's the big challenge with simulations. Simulations are very good while you're immersed in them, but you actually need a teacher to help you to connect the dots and relate it to the outside world. So let me show you how this game works. If anybody of you is having trouble with addition, this is your chance. It actually works. So far, I haven't tested with 400,000 kids, but so we have 7 plus 46. This is what we want to teach kids, okay? This is one of the latest levels. So imagine a kid that only knows how to do single-digit addition, okay? And you want the kid to be able to solve this. So 7 plus 6, 1, 2, 3, 4, oops, okay. 1, 2, 3, plus 1, okay. This is what we want to get at. So how do I teach somebody without any words, just with games, just with a game? The procedure, how should I say, the choreography, the skill to do this. So let's see how we can do that. I'm going to be skipping many levels, but the idea is like in every tutorial, you introduce a concept, and then you practice for a few levels, and then you introduce a new concept. So let's start. The first level in a tutorial has to be very, very easy. Anybody should be able to do it. Even a rock under the sea, okay? If it's not obvious, then you're not doing it right. So the first thing you see is like, okay, I'll do whatever that hand, the magic hand tells me, and get this mouse inside a castle. Can I get sound on the... Okay, I did it right. Okay, now I'm doing this, I'm getting 2. You see what I'm getting? Okay, you get every single mouse, and you get them inside the castle. Well, oh, don't worry, it's okay. I mean, the sound is very useful for giving feedback, but now there's a new concept. Before, I just dragged the mice. Now, I have to click here for the right amount of mice. So it's 1, 2, 3, 4. And this seems quite easy, but this is targeted at kids, 6-year-old kids. And it takes them quite a while to do all the addition by hand. Okay, I'm going to skip this. Now you see a mysterious shadow, which is important to grab their attention. And 1, 3, 4, 5. 1, 2, 3, 4, 5. And now there's a new button there. And that's the interesting thing. When an adult plays this game, the first thing they say is that, what is that button for? What is that button for? They start freaking out. Kids never do that. They just do whatever they learned before, and then when nothing happens, and they see the pulsating button, they just press it. And then the dragon appears. Because I really want to encourage kids to get into this whole Game of Thrones thing, because it's healthy for them to learn that politics are complicated. So I'm going to skip a new one. And again, adults freak out here, but kids, they just do whatever they learned before. So they just get first the mice here, and now they get the cats. Imagine that I put the wrong amount of cats here, and then you hear boing, which is the international sound for you messed up. So 5, they're happy. Hey! So I press this, and then the dragon appears, and our little friends are safe in their castles. Okay, I'm going to be skipping levels. Well, now we have a cat at the wrong place, on the wrong castle. He's on the blue castle, he has to go to the orange castle. So, boing, he can't get there, so I'm going to be pressing this. Okay, and now I got him on the right castle. Now the same thing with mice. Now I can summon the carriage. And now something interesting happens. In this level, you learn what happens when you get 10 mice together. Let's see what happens. They become a cat. And you've seen some numbers there. Kids don't really care about that. I mean, again, adults were like, what were those numbers about? Kids, they just don't care. They continue doing what they learned before. I'm going to fast forward. Remember, winter is coming? Well, it's here. And now what happens is that, well, we get plenty of new characters, but actually the mice are frozen and you cannot move them. So what you learned before is not working now. But still the logic remains. You count the right amount, and now they automatically go down. Same thing, same structure, just a little twist. Okay? And then we do the same thing with 2 castles as we did before. I'm going to be fast forwarding here. Now we have the wizard made a magic carriage. So the chariot, if I press it, it automatically gets 10 mice and brings it here. And if I do this, first I get 2, and now I just move it with the little friends, and 5, 7. Okay, I'm gonna be skipping for more levels. Yeah. And now suddenly, so the game is getting more and more abstract as you progress. Now you have numbers, but it's the same thing. Okay? Same kids, they feel comfortable because they keep doing whatever they were doing before, and now instead of having 2 little mice silhouettes here, you have a number 2, but it's the exact same thing. And now the characters get replaced by numbers, and now actually the numbers get covered with smoke, and as we progress, we slowly start getting to where we want it to be. So 28 plus 24, 8 by 4, where kids first press this button, and 2 remain. So they move 1, the 2 mice go there, and here 5. So basically they managed to do 28 plus 24, 52 without absolutely any text any guidance outside the game. And of course, this is where we wanted to get. And as we progress, the idea is that you can get up to millions. So in 1 hour and a half, a 6-year-old kid can learn the basics on this procedure. And you may say, well, they don't really understand what they're doing. True. But this is not supposed to replace a math class. It's supposed to replace a very cumbersome procedure that takes quite a long time to learn. This is actually the easiest one. Long division is the headache for most teachers and most students because it's so abstract. Why this works better than the traditional method? Well, because you get instant feedback. If you did something wrong, you get instant feedback. If you did something right, you get instant feedback. Imagine learning this traditionally in school. If I gave you 20 additions to practice and you messed up the first one, you're just going to learn that you made a mistake when the teacher returns your homework tomorrow or next week, or maybe in the next few weeks. But here it's almost instantly. So this is something that it's being learned on every school, every year around the world. If we were able to optimize, improve the time that usually takes to learn these procedures, just by half of what it takes normally, we'll be saving 8 billion hours per year globally. So these are things that computers can do much better than teachers. But they cannot replace the teacher. The teacher should be there just like a coach to know the strengths of every student and encourage them to go further, explain to them why this is good for, in addition to saving cats and mice. That's the challenge. That's one of the challenges that we're facing by getting kids online, but not because we want them to have fun, but because we want them to be challenged. Again, I'm going to insist on that because it's essential for understanding the difference of games in education. So in Brazil, actually, you have probably one of the most brilliant game designers that ever existed. He passed away a few years ago, Augusto Boal, who developed the theater of the oppressed, based on Paulo Freire's work. He's actually a genius. He has all these games, not about math, but about social justice, about mental health, about communication. All these simulations that allow adults, children, everybody to iterate, to explore problems by making mistakes and learning from your mistakes, other people's mistakes, and trying to understand everybody else. I strongly encourage you, if you're interested in serious games, if you're interested in using games for teaching, to look, especially one of his books, Games for Actors and Non-Actors. It's really, really, really useful. So, we're facing, just to sum up, we're facing a challenge as a civilization, which is more and more, and this is a trend that it's here, but we're not seeing it as strongly as we should. More and more menial works are getting automized. More and more works are going to be replaced either by algorithms or by robots. The Japanese already invented robots that can go to the fields and pick up strawberries, and they work 24 hours, 7 days a week, every year. They don't go on strike, they don't get sick. So this is happening, and not just on the fields. I mean, it's happening with voice recognition. That Siri is very helpful for getting directions, for example, on your phone, but the same technology is replacing telemarketing. Okay, it would be great if somebody destroyed telemarketing at all, but that's a whole different issue. So most kids that are right now studying, they're going to be doing jobs that did not exist when they were born. If you were born up to 200 years ago, 99% chance would be that you'd either be a farmer or a housewife. That was it. Until the Industrial Revolution, where you could be a worker, or the 20th century, where you could be a clerk or doing some bureaucratic service work. But now, more and more, we're getting these new jobs, and we do not know what the future is going to be like. The smartphone is 8 years old. Can you imagine living without a smartphone? Well, we should try, but anyway, that's a different talk. So how do we prepare kids for a future that we have no idea how it's going to be like? Well, actually, that sounds like a very tough question, but it's already been solved. Nature solved it. Human beings, for better or for worse, we took over this planet because we evolved by connecting two parts of our brain. We evolved connecting curiosity with pleasure. We evolved to get pleasure out of trying new things, out of see what happens if I do this or that. That cognitive process is play. And play is the way we learn some of the toughest things on life. We learn how to socialize, how to control our bodies, how to communicate. Actually, the ancient Romans had the same word, ludus, not just for play and games, but also for school. So the use of games in education is not just trendy. It's part of the way we understand reality. It's not the only one. It's not going to solve every problem we're facing, but it can definitely help. So, just to finish, we have all these technologies. We have the book, we have videos, we have many technologies for learning, and games are not the same. They're not better or worse, they're just different. And one of the main differences is that when you finish a book, when you finish watching a film, it says film, the end. But when you finish playing a game, it also says game over, which is the end, but it says something else. It has a little button there, a little button that says, try again, play again, try something new, make a new mistake, learn from it, try again, make more mistakes. I'm giving you more opportunities. Games give people more opportunities, and that's why we have to use them for opportunities. Thank you so much. Thank you very much. Thank you.